So today we will talk about the transformation values that we can take from our parent graphs and now create them into some type of transformation. So if you recall, these are what our parent graphs look like. We have y equals sine of x and then y equals cosine of x. So you should start thinking about what transformation values did we learn already that we know we can take to any function, put them on, and then transform them. So if you recall, we have our a value, our h value, and our k value. You should be accustomed to those three transformations. If you recall, a was all about vertical stretches, shrinking, and reflections, or flips. H was about moving left or right, and then k was about moving up or down. So the new variable, or the new transformation value that we're factoring in now, is this b. So we're going to learn all about what that b does in terms of our sine and cosine equations. So these are our new general formats for our transformed functions. Remember, we have a plus or minus because if it's plus, it's moving one direction. If it's minus, it's moving the other direction. So keep that in mind. You're going to have to figure out what that means, what direction you go. So we always start with our parent, and then we now have our transformed. So let's get started with what each of these mean. So I color-coded these to help us try to get in the mindset of what each represents. So we'll start with the a value. A value, in this case, because we're talking about curves or waves, this is referred to as our amplitude. So you should be comfortable with this term already if you know a little something about waves. So remember, our amplitude, if this is our vertical stretch, shrink, or our flip, that's what it tells us to doing. Remember, a vertical stretch means that the number is over 1. A vertical shrink means that the number is below 1 but bigger than 0. And then, if you have a reflection, we just have a negative value. What's important to note about the amplitude is we always refer to it in its positive sense. So as we go through some examples, you'll see that we're going to be taking the absolute value, and instead of saying it's a negative 2, for example, we'll say that it's 2, but then it's flipped. So just keep that in mind as we go through amplitude. So again, amplitude, we're either stretching it vertically, or we're shrinking it vertically, or then reflecting it over. So for example, if you were going up first, you now might be going down first. Next we have frequency. So this is our new value that we haven't really talked about at all. Frequency is actually a horizontal stretch or shrink. So it's kind of like that vertical stretch, but now we're talking about it in terms of a horizontal stretch. And our frequency basically helps us find our period. So this leads us into our period. Our period isn't exactly a variable or transformation value on our equation, so it's always found based on knowing our frequency. So that's really the purpose behind frequency. Without a frequency, we don't know what our period is. And our period can actually tell us how long a cycle is our graph. So basically it tells you the distance from your starting point to your ending point. That's what a period is for. It's kind of like if you think about for timelines. What is a general period that something happens in? Like if we're talking about an era or if we're talking about a decade, that time period. So it's all about basically a distance of time. So in order to find our period, we use the formula P, where P represents period, times B, where B is your frequency, and that's equal to 2 pi. So a way that I like to remember it is peanut butter is equal to 2 pi. It's like peanut butter pie. So P times B equals 2 pi. So when you're given your B value, you plug it in for B, and then you're going to solve for P. It's a one-step process. You just divide both sides by B. So then we get into the phase shift. So the phase shift is our horizontal movement. We probably remember it as our horizontal shift, left and right. That's the same thing, but just when we're talking about waves, we refer to it as a phase shift. So again, if you remember, this works opposite. If it's a positive h, we're actually going to the left, and if it's a negative h, we're actually going to the right. And then last but not least, we have our k value, which is our vertical shift. So that's either moving up or moving down. And that works just the same depending on the sign. So if it's positive, it's up. Negative, it is down. Okay, so let's actually start by identifying our different values. So we start with our a value here. If I have y equals 3 sine 5 of x minus 2 plus 7, again, I color-coded it to help us make it a little bit easier for the first few examples. So our amplitude is 3. That's our first value. It's right before our sign. And because it's greater than 1, we say that it's a stretch. Next up in the equation is our b value. So our b value is always right before that x value. So whatever that is, that's our frequency. So if our frequency is 5, now we can use it to find our period. So I'm going to plug 5 in for b here. So if you see the work here, we now have p times 5 equals 2 pi. Well, I divide both sides by 5, and that's how I get my period to be 2 pi over 5. Then we have our phase shift, so that's the next part of our equation. So it is a -2, which really means that we are going to the right. So we rewrite 2 and right. Then last but not least, our k value is 7. So it's 7 and it's going up. Next one over here, we have y equals -3 cosine of 1/4 x minus 4. So we start with our a value. Our amplitude is 3 and we know it's flipped. Then our cosine of 1/4 x. So now what's the value in front of our x? That's our frequency. So our b value is 1/4. So now we have our frequency, we have to use it to find our period. So if I have p times b equals 2 pi, I plug in 1/4 for my b value, and now I'm dividing both sides by 1/4. If you recall, dividing by a fraction is the same thing as multiplying by its reciprocal. So that's why I'm now taking 1/4, flipping it over, making it 4 over 1, and now I just multiply across. 2 times 4 is 8, and then I have pi over 1, so that's why the period is 8 pi. If you notice, there's no parentheses here, so that means that I don't have a phase shift. Okay, so that's kind of a key hint here. If you have the parentheses, the number inside that parentheses, that's your phase shift. Lastly, we have a -4, so that means we are moving down. So now I'd like you to pause and try this out on yourself. Identify your A, B, H, and K values. And then also identify your period. When you're finished, come back on the video and then look at the next slide to check your answers. So let's see how you did. Did you get A is 1/4, shrink, B is 2, then for our period is pi. There is no horizontal shift or no phase shift, and there is no vertical shift for the first example here. Then over here, we have y equals 3 cosine 1/2 x plus 4. So it is, our amplitude is a stretch, and it's 3. Our b value is 1/2. We use the equation p times b equals 2 pi to get 4 pi. And then there's no phase shift, and it is going up by 4. Down here, notice it is a negative, so that's why I'm now saying it's 3.5 stretch and a flip, and I'm not talking about it as a negative number anymore. Our b value is 4, our period is pi halves, phase shift is pi halves to the right, and it's going 1 down. Over here, a value, it's 1, which means there really was no transformation, so you can't really say anything about it, you just know that the a is 1. Our b value is 1/3, our period is therefore 6 pi, we're moving pi to the right, and it's going 2 up. So now that we have a little bit of practice talking about the transformation values, let's go ahead and talk about finding the range. What's kind of nice about the range is you don't even have to graph it in order to find the range. That's kind of like when we talked about our exponential functions. It's all relying upon our transformation values. So the only two values that you need to think about when we're talking about the range is the ones that affect the y. Well, which ones affect the y? That would be our a value and our k value. So think about this as like a driving range. I created this acronym CAR. It's like driving a car. That's how you find your range. So what that means is you take your k value plus or minus your a value, and that is equal to your range. So when I get k plus the absolute value of a, that's going to be my upper bound or my highest number. When I get k minus my absolute value of a, that's going to be my lower bound. Because remember, we always write in terms from our lowest value to our highest value. And because these are waves, they're actually going to include our lowest value and our highest value, so that's why we use brackets. Okay, so for example here, if I have y equals 3 times sine of 5, x minus 2 plus 7, I identify my a and my k value. So I start with my k value. Here my k value is 7, so I'm writing 7 twice, and then I'm going to add 3, but I'm also going to subtract 3. So that means that my range, therefore, is 4, 10, included with my brackets. For my next example, if I have y equals -3 cosine of 1/4 x minus 4, I again start with my k value, so that's -4, I write that twice, and then I'm going to add and subtract the absolute value of -3. So remember, the absolute value of -3 is actually a positive 3, so I now have -4 plus 3, which is -1, and -4 minus 3, which is -7. So overall, my range goes from -7 to -1. So take a second real fast to read that over and make sure that you have that down. Okay, so now it's your turn. Go ahead and try to find the range of each function. Again, think about car. Start with your k value, then add and subtract the absolute value of your a value. And then check back on the next slide to see how you did. So hopefully you're taking a look at this slide and seeing that you matched up with your answers. Okay, so now that we had our equations and we were able to identify our a, b, h, and k values, can we now go the opposite way? If I give you the transformation values, can you actually go back and write a sine or cosine equation? So let's test it out. Say I have a is equal to 4, b is equal to 2, h is equal to 0, and k is equal to 3. I can actually now take all these values and plug them back where my equation is supposed to be. So if you recall, our a value always starts our equation, so that's why I put 4 first. Then it asked me to write a cosine equation, so I write cosine. My b value is 2. There is no phase shift, so it's just put x in parentheses there. You actually don't need your parentheses. It's kind of up to you if you want to put them. And then we have plus 3 because our k value is 3. So that's one way where it's just given straight to you. Next, you might have it written out in words, so you really have to know what each of those values represents. So now I'm told I want a sine equation, so that's why I start with my sine equation. I'm told my amplitude is 2, so I'm now writing a equals 2. It's been shifted pi over 6 to the left, so I'm writing pi over 6 to the left. It's going down 3, so I know my k value is going to be a negative 3. And then my period is 3 pi. So if you notice, we aren't given all the information to actually write our equation because the period isn't present in our equation, it's the frequency that's present in our equation. So I'm going to use my period in order to go backwards and find my frequency. So this time, since I know that my period is 3 pi, I'm going to substitute p with 3 pi. It's multiplied by b, and that equals 2 pi. So I'm going to divide both sides by 3 pi, and if you notice, since I have a pi on top and a pi on the bottom, those pi's are going to cancel, so I'm left with 2/3. So now I just put it all together in my equation. And the thing I have to think about is remember that I know it's pi over 6 to the left, so it has to be the opposite sign, so that's why it's a plus pi over 6 here. So now you give it a shot. Write a sine function given the amplitude is 5, it's flipped, the period is 8, the phase shift is 2 pi to the right, the vertical shift is 4. And then write a cosine function given the amplitude is 1, the period is pi, phase shift is pi to the left, and the vertical shift is 0. So give that a shot now, and then check back on the next slide. So hopefully this is what you got here. If you need to, pause it so you can get it down, and then if you have questions, please let me know on this one. Okay, so now that we went through identifying the transformation values, identifying the range, then taking your transformation values and writing an equation, it's your turn to practice. So we're going to ask you to please fill out this Google form that you have here. Obviously, it's an assignment on Google Classroom because you're probably not going to be able to click from the video. And then if you want a little bit more practice before you go ahead and actually take that, there's 6 problems here, which we put the answers on the next slide so you can get a little bit more practice of just identifying those values, because that's the biggest thing you need to know. You need to know where they go on the equation, so start getting to memory the y equals a times the sine or the cosine of b times x plus or minus h, parentheses, plus or minus k. So give that a shot. If you want to do a little bit more practice, check these out. I'll go to the next slide so you can check them. Otherwise, go ahead and complete that task. So here's your key for that.